Okay, the next concept that we will look at is the idea of Python generators. Generators are very similar to iterators, but the only difference is that it's more memory efficient when you are trying to access rows in an iterative manner or something like that, right? So I'm going to give you an example of how it works. So I can say define simple, let's put a simple generator. Um, Spelling is correct? Nope. Yield 1, right? Yield 2, yield 3, right? So you would think that, when you run this code, you would think that all of these normally, right? All of the lines execute, okay? But what happens here, anytime, converting why is this red here? There is something? Hopefully not. Right? Anytime you call a function, all of these lines of code execute. But the way generators work is that it somehow tracks which row or which yield it was working on it last and what is the next one, right? So what I'm going to do here is simply I can do two things. I can say for v in simple gen, right? Print v, hit that button. Hopefully nothing's wrong here. Indentation error. Is this too much? Oh, this is playing around. No wonder. I have a code mistake. So let's fix that. Fix that too. Now it still looks weird, doesn't it? All right, so it prints the three values, huh? Then I can change this. Just because we have this yield also converts, it turns this method, this function into a iterative function. So what that means is that I can do something like this. I can say, um, you know, my gen is equals to simple gen, and then I can print next my gen. All right. I can do this. Let me do this twice. So when I take that line of code and I put one here and I run that, it prints 1 and 2. I'm going to copy this twice, okay? Just to show you that because we have three yields in here, so I should get some kind of funny error saying, hey, what are you trying to do? And that is exactly what's going to happen. It's going to give me an error say, I don't have a fourth one, right? So let's go ahead and change this to the data frame that we've been working on. All right. Earlier I showed you in the other video, I can do something like I can do let's change it. I can do something like this. I can say for row in df, what is it? RG data frame, right? df iter. All right. And then I can simply do print row. No, 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 no. Why am I? That's weird. I'm missing something. I- Iter rows, right? Iter rows. I knew something was wrong. I'm like, that just doesn't sound good to me. Right now, if I run that one, it's supposed to give me a whole bunch of df. Nope, nope, no, no, no. All right. So, this is one way to loop through the data frame and go through each rows and printing, right? The problem with this method is that, I mean, to begin with, the data frame is all loaded into memory and maybe it's not actively being used, but when you have this loop, all of those comes active, right? And you basically loop through each one. Likewise, when you're changing a class that has a data frame in it using iter, concept, it does the same thing too, right? I mean, the data frame is there, is in the memory, but it's not actively being used because I'm not using it. But as soon as I do, a next of that sort, all of those data, million rows, for example, comes into active, and then guess what? I'm looking through the million rows to get my row given to you. And that is where the concept of memory deficiency comes in. Okay, we can change that using the idea of yield, right? Generator, and this is pretty easy to do. So I'm going to change. Let me just take this out because I don't need that anymore. Defn OZ, and this is just a function, not even a row generator. Generator spelling correct, hopefully. So data frame right here, right? And for row in df dot iteros, right? Yield. The amazing thing is that you would think that, hey, anytime you have a loop in that manner, it will execute that many times and do that yield, right? Do that yield those many times. Not in a generator function, no. It will not. It will keep a track of where it is, but yet not go through everything until it's required to do so. All right. So load data here, and I'm not worried about that code, right? I should take it out. Kind of confuses me a little bit. DF generator, that would be Aussie, put DF right there, right? So now, if I go ahead and simply do let's do a loop here. Gen, right? Why is my load data not defined? Did I pick it out? All right. So it's running it. Okay. You may also think that, hey, since the professor has got another loop here, I mean, it seems like it's looping through each one, but the way it's working is that it's only grabbing, it's doing like a lazy get of that row that is needed. So even though all the data frame is loaded in the memory due to this line of code, um, due to the DF, it's not active, right? It's not active until I access it. So when I'm using a generator, it only activates that row by row, right? Not the whole data set. So that is how it becomes memory efficient. I wish there was a method, a way where we can actually count and see, compare both of them, right? The iterators and the generators to really see what rows or how many rows are active in the memory and how it helps us in terms of memory management. But that's the whole concept. I mean, I have never worked with, very big, large data frame that has caused me a problem, right? So it's always worked for me. But it's a concept that we should implement in this module. The reason is because later, as we get towards machine learning and model training, right, you will be using large data set. In terms of generator would help you manage memory better and not crash your your project, right? All right. So hopefully this helps and gives you some ideas. Give it a go and see how this works for you. Thank you.